In this video, we're going to talk about linear inequalities in two variables. We're going to be reviewing some of our graphing techniques for graphing lines. Graph linear inequalities in two variables. Consider the graph. The graph of the line x plus y equals 5 divides the points in the rectangular coordinate system into three sets. Here's the line x plus y equals 5. Those points that lie on the line itself, that's a set, and satisfy the equation. This line, called the boundary line, divides the two regions in the plane that are graphed by the following two inequalities. X plus y less than 5, x plus y greater than 5. Those that lie in the half plane above the line and satisfy the inequality. Those that lie in the half plane below the line and satisfy the inequality, x plus y is less than 5. Graph linear inequalities in two variables. Graphing a linear inequality. Draw the graph of the straight line that is the boundary. Make the line solid if the inequality involves equal to in it. Greater than or equal to or less than or equal to. Make the dashed line if the inequality involves just less than or greater than. Choose a test point. Choose any point not on the line and substitute the coordinates of that point into the inequality. Shade the region that includes the test point if it satisfies the original inequality. Otherwise, shade the region on the other side of the boundary. When drawing the boundary line in step 1, be careful to draw a solid line if the inequality includes less than or equal to or greater than or equal to, and a dashed line if it's just less than or greater than. So let's graph this inequality, and since it's equal to, y is greater than or equal to negative 2x minus 1, I'm going to draw a completely solid line here. So y is greater than negative 2x plus 1. This equation is actually in slope-intercept form. So if you remember how to graph slope-intercept form, the y-intercept is negative 1. The slope is negative 2, so over 1 down 2. Okay, so that line now is dividing the coordinate plane into two half planes. So I'm going to pick a test point to decide which side I'm going to shade on. I'm going to pick the test point. How about the origin? The point 1, 1. If we pick the point 0, 0, I don't know why I said 1, 1. The point 0, 0. If we plug that into the inequality, 0 is greater than or equal to negative 2 times 0 minus 1. Is 0 greater than or equal to negative 1? That is true. So I'm going to shade on the side that the test point was on. So since it's on this side, we're going to shade all the points in the coordinate plane on that side of the boundary line. Okay? So a test point will tell you which side to shade. Had I plugged in the point 0, 0 and it gave me a false statement, we would shade on the side opposite of the test point. Let's try another one. 2x plus 5y is greater than negative 4. So this time, since it's not equal to, we're going to use a dotted line. I'm going to do intercepts to graph this one instead of the slope-intercept form. I know the x-intercept would just be pretending like the y is not there. So 2x equals negative 4. X would equal negative 2. So I'm going to plot a point on the x-axis at negative 2. And if I were to pretend like the x is not there, 5 equals negative 4. Negative 4/5 on the y-axis, which we know that's almost down to negative 1. So there is my 2 points that define my line. So I'm going to do a dashed line. And that's Probably not a great line, but you get the idea. We can see where the origin is, so I'm going to pick that as my test point. So let's plug it in and see if it makes a true sentence. 2 times 0 plus 5 times 0 is greater than negative 4. 0 is greater than negative 4. That is true. So we are going to shade on the side of the test point, which means we're going to use all the points that are above the boundary line. Okay. Graph linear inequalities in two variables. If the inequality is written in the form y is greater than mx plus b or y is less than mx plus b, then the inequality symbol indicates which half plane to shade. If it's greater, you'll shade above the boundary line. If it's less, you shade below the boundary line. This method only works if the inequality is solved for y. A common error in using this method just described is to use the original inequality symbol when deciding which half plane to shade. Be sure to use the inequality symbol found in the inequality after it is solved for y.